Well, it's another time where I would like to take this opportunity to welcome all the physical and even online students into our interesting institutions that call the Tanzania Online Institute of Technology. And I would like to take this opportunity to welcome the departments of electronics. And today we are going to discuss a very interesting module that's called instrumentation and measurement. I have some physical students who are actually going to join with us in these moments of learning. These contents are actually very important for the technical personnel, whether that you're technicians or you are engineer. It's very important for you to have theoretical concept. In this module, we'll be having a theoretical part, simulation part, and then we'll be having real experimental part. My name is Olenjolai. It's the first time. I would like to take this opportunity just to welcome you into the interesting moments of learning about the manuals of electronics, measuring and testing instrument. So these are the serious content. I would like to ask you to make a follow-up on what we are going to discuss. But again, in case you have a question, you may ask it and stay connected in order to enjoy the contents that we have prepared for you. So I wish you a good learning of instrumentation or of lecture 5. So the name of the module is called instrumentation measurement. We are in chapter 1, introduction to instrumentation measurement. And today we have to finish in this lecture, this first chapter. And we are in lecture 5 that's called the user manuals of electronics, measuring and testing instrument. So this is a very important topic in academics and also very important topics in electrical and electronics industries. So either that you wish to work either in academics, means teaching in different institutions or colleges or universities or schools, or you want to work in industries and different companies, I believe that one of the departments that you'll be engaged in is departments of instrumentation and measurement. So I believe that you are serious and will be serious with this content. And then let me appreciate the presence of some physical students. Then we are going to start our class. How are you, electrical engineering students? How are you, electrical engineering students? Are you ready for lecture 5? Yes. Well, so even myself, I'm ready for lecture 5. So lecture 5 is called user manual. Say user manuals of electronics measuring and testing instruments. Pardon? Read it again. Okay, so let us do a quick review of the previous lecture. Let's say lecture 3 and lecture 4. Just we are going to do the quick review. So actually lecture 3 and lecture 4, we've been discussing about 10 parts, 10 main parts, 10 main parts of 40 of user manual. 10 main parts of 40 user manuals of 40 measuring and the testing instrument. So that's been the title of both lecture instruments. Then, firstly, we mentioned these 10 main parts, where that we find them in most user manuals of electronics measuring and testing instrument. The first part is called introduction. Say introduction. So user manual should have introduction. And introductory sentence is always thank you for purchasing. So the manufacturer always appreciates for your decision to purchase his own product. Okay? So thank you for purchasing a digital multimeter. Thank you for purchasing our digital signal generator. Thank you for purchasing our oscilloscope. So that is very important sentence. And then another important sentence in introduction. The manufacturer will ask you to make sure that you read careful the user manual from beginning to the end before using his or her product. And the manufacturer will tell you why, in order to use it safely and we call it effective. Okay? Okay? So in introduction we have appreciation sentence. Thank you. Okay, in most cases. But against another ones we have a polite language. Please read this user manual through. That's very important. Before using using the given or the product that you have purchased from them. Okay? The second part is called the safety precaution. Please, students, when I ask you a question, please answer the question. Safety precaution. Say safety precautions. We discussed the 5 safety precautions that we learn in most of the user manual for electronics measuring and testing instrument. The third part is called the product overview. Say product overview. Say product overview. So these one are the safety that you have to take when you're using the instrument. And especially if you're using the electric instruments, measuring instruments which are operating with high power. So you know that it can endanger your life. Then, so that's the product. So in product overview, actually the manufacturer gives you a brief description about the product that you've purchased. Okay? So actually in this product overview, it actually presenting the packaging content and the key components. So you talk about packaging components, first of all, the name of the measuring instrument that you've purchased. And then you can actually that if within the package there are batteries, or there are power supply, or there are test leads, or there are probes. Okay? Then the next part is, we call it, the next part is very important. We call it what? We call it getting started. So you have read there, say getting started. I can say loudly getting started. So the manufacturer trusts you that you have read introduction. You see, can do even your exercise today. That's your exercise book of instrumentation measurement. It's a paper. Yeah, that's what I told you that. It has been an amazing day for you. So the manufacturer actually trusting you that you have read the introduction, you have read the safety precaution, you know the safety that you have to take care, you have read the product overview. Then in this section, the manufacturer want to train you, to teach you about how you can start using that product. Are we together? Are we together? Yes. Yeah. Then the fifth part, which I left at assignment for the electrical 2, is called the operating instruction. Operating or operation instruction. Operating instruction. Say operating instruction. Operating instruction. Say operating instruction. Operating instruction. So in this part, the manufacturer will answer the questions that you want, or you can be asking, how can I operate this product? How can I operate the digital multimeter? How can I operate the signal generator? How can I operate the oscilloscope? How can I operate the clamp multimeter? How can I operate maybe a spectrum analyzer? Then the 60 part. The 60 part is called the calibration. Say calibration. Calibration and duty and the accuracy. Calibration and the accuracy. That's the 60 part. The 7th part is called the troubleshooting. Say troubleshooting. Say troubleshooting. Then number 8 is called the maintenance. Maintenance and duty and the care. So number 8 is maintenance and the care. Then number 9, say maintenance and care. Maintenance and care. So that part will actually train you how you can maintain. You can do simple maintenance. And then after that, how you can take care of it. Number 9 is called the specification. Say specification. Say specifications. So the 9th main part will teach you about specification for that particular product. In our case, specifications of that electronics measuring and testing instrument. Then number 10 is called the warranty. Say warranty. Warranty and duty. Warranty and support. Warranty and the support. Those are the main part. So the user or the manufacturer will give you a warrant and also will tell you how he or she can support you in case you encounter any challenge. Are we together? So in lecture 3, we discussed about introduction. We discussed about safety precaution. In lecture 4, we discussed about the product overview. We discussed about getting started. And also we discussed about operating instruction. So in this lecture 5, we are going to discuss calibrations and the accuracy and the next main parts. Class, is it clear? Yes, sir. And another thing that you have to remember, this is the systematic arrangement. Listen, in formal, or I think in all, hundreds manuals of electronics measuring and testing instrument, a manual is arranged in this systematic order. Hello, please listen. Listen, please. Listen and look. This is systematic arrangement of formal. It means that this is the international standard of writing engineering manuals. Do you understand what I say? It means there are standards which have been set. Because remember that the digital multimeter made in China might be sold in different countries in the world. Okay? The oscilloscope maybe which has been made in Japan will be sold into different countries, and sometimes they might be written in different language. Okay? So this is the format. Say format. I used to say that when we have been teaching about English language, we taught you about the format of application letter. How can you write application letter? Do you remember? We taught you about the format of outright friendly letter. And for us who are adult enough, we know that those days when we are in Form 1 or primary, in case we want to communicate with ladies, if you're a gentleman or you're a boy, you know that sometimes you don't have confidence of physical communication. You used to write a friendly letter. And that friendly letter you deliver to maybe that lady's friend. Or if a girl wants to communicate with a boy, for us who have been in 1980, right? So then the lady, in case want to communicate a sensitive message, then actual writing will be used, right? And the message delivered to whom? A boy's, maybe as that particular boy's friend. Please deliver this letter to your friend. You understand for the adult people, right? But for these teenagers, they don't experience that. They don't know even how to write friendly letter. Why? Phone. Give me your number. And then buy the bundle during the midnight, having a free bundle. The boy and the girl will be having long conversation until the morning. When they get to the class, they are slumbering. Why? They didn't sleep. The teacher might think that these students are studying so much while they have been communicating. Okay. So let us discuss about the 60 main part, which is called the calibration, class A calibration. So this is the formal way. This is number 1. Listen. This is number 1. This is number 2. This hello. Listen. This is number 3. Number 4. You cannot say that this is number 1. Number 2 is getting started. No. Okay. You cannot say that number 1 is introduction. Number 2 is calibrations and the accuracy. No. You cannot say that number 1 is introduction, number 2 is safety precaution, then number 3 is maintenance and care. No. Okay? Are we together? Yes. So in case even I ask you questions, I might ask you a question systematically. You should not say that, just mention the main parts of, no. You have to mention them systematically. And you should not claim. This, I'll try my level best to teach you in a simple language in such a way as the electrical engineer, these parts, because regardless, I'm teaching about user manual for electronics, measuring and testing instruments, but the same format used for electrical instruments, and even mechanical instruments, and even biomedical instruments. So the trick I'm teaching you, just see, maybe you're not engaged with most industries, but you remember what I've taught you. Because this is the critical issue when it's come for the technical, and especially for the maintenance of the particular system. Are we together? Yes. So number 6 is a very important part, calibration and the accuracy. This is a very important part in engineering. Class say calibration and accuracy. Calibration and accuracy. Say calibration and accuracy. Calibration and accuracy. What the means of calibration? Why do we need to calibrate an instrument? So calibration is what? Setting an instrument to give the, listen. Hello? Calibration is actually a process to set an instrument according to the standards. For instance, if measuring 1 ampere, then there is a reference standard that actually has to give a precise 1 ampere. Okay? So we set the instrument to follow the standards. And accuracy, you know the meaning, eh? What is accuracy? What is the difference between accuracy and precision? Accuracy is the degree of what? Of the measured value to be closer to what? Expected value. While precision is the degree of what? Different measurements or different readings to have close values. Right? As engineer, bear that. So in calibration the accuracy, most manuals, just to give you this description. This is quotation. These are not my sentences, I have quoted them. Then the sentence is start that to ensure accurate measurements. To ensure accurate measurement, then we have in bracket measuring instrument name. Measuring instrument name. So to ensure accurate measurements, then you'll find the measuring instrument name should be calibrated regularly. Should be calibrated regular. So this is the sentence from most user manuals. Listen. How does it say? To ensure. Say ensure. So in the user manuals there's no any way switch has been underlined. I'll try to underline to show you the keywords. You know the meanings of keywords? The important words, right? So to ensure accurate measurements. Remember that these measuring instruments, we want them to use to do measurements, to find numbers. Okay? So in order to ensure accurate measurements for any electronics measuring instrument, then here in the actual manual, user manual, you won't find measuring instrument name. You will find a particular name for that product. So for instance, if it is digital multimeter, hello. To ensure accurate measurements, the digital multimeter should be calibrated regularly. Okay? Or to ensure accurate measurements, the digital oscilloscope, maybe of a particular number, a unique number, should be calibrated regularly. Are we together? So we say that measuring instrument name because we have so many measuring instruments, and in next chapter that called the electronics measuring and testing instrument, we will learn almost 10 measuring and testing instruments. Okay? So that's why that here we use measuring instrument name. Are we together? Then another important information in calibration the accuracy is this one. Then the manufacturer will teach you how to calibrate. So where we call it calibration process. Say calibration process. So the next part now is calibration process. If you don't know the procedures of doing calibration, don't think that calibration is simple. It's hard. Calibration what is? Process. So calibration process say that follow the procedure. Follow the procedure below for calibration. So for calibration, if applicable. If applicable. So this is the calibration process. It should be bolded, or it may be bolded. Say calibration process. So follow the procedure below for calibrating, if they're important according to your instrument that you want to calibrate. Number one, the first procedure. Disconnect the instrument. Disconnect the instrument from any power source. From any power source. That's the first process. So whenever you want, listen. Whenever you want to calibrate a particular measuring instrument or any instrument, first of all, you have to disconnect that instrument from any power source. From any power, that's number one. And there is reasons to do so. Number two, and this when you say that disconnect the instrument from any power, especially for the AC operating instruments. AC operating what? Instrument. Then number two, we say that use a known reference standard. Use a known reference standard. Example, precision resistor. Precision resistor for the resistance. For the resistance, or a known voltage source, or a known voltage source. This is the second procedure for calibrating. Use a known reference standard. Say reference standard. So use a known reference standard. Example, precision resistor for resistance, or a known voltage source. Stop writing. Let me explain this process. For instance, in digital multimeter, we have ohmmeter. We have what? We have ohmmeter. Say ohmmeter. Say ohmmeter. So ohmmeter is actually measuring what? Resistance. So you wanted to calibrate ohmmeter in the digital multimeter. What should you do? Okay? Then what you are supposed to do, you have to find precision resistor. Say precision resistor. So precision resistor, these are the resistance we have, which actually have small, I would call it small tolerance. Small what? Tolerance. So the tolerance you might find that maybe 0.5%. When you say tolerance, it's actual variation between the maximum value of resistance and minimum value of what? resistance. Some of the resistors, they can have tolerance of 10%. So once you have that precision resistor, and you should know the resistance of that resistor. Okay? So then, for instance, if the standard or this reference standard resistor, its resistance is 10 kilo ohm, then the digital ohm meter must also measure resistance of 10 kilo ohm, or maybe 10.1 kilo ohm, or maybe 9.9 kilo ohm. In case you are not listening. You are not listening. That's why I'm waiting. What did I say? You didn't understand. Let me repeat. We say that in order to calibrate the particular instrument, measuring instrument, we should refer we should use known reference standard component, right? So example, we say precision resistor. Say precision resistor. So in precision resistor, actually we can measure its resistance by using ohm meter. Okay? So ohm meter measure resistance of the resistor. Again, what the resistance of this resistor? For instance, we say the resistance of precision resistor, the resistance of precision resistor is 10 kilo ohm. 10 kilo? 10 kilo ohm. So it is 10 kilo ohm. What do we say? We say, well, so if this ohm meter is accurately calibrated, we expect if you use it to measure resistance of this resistor, to have resistance with a very small deviation from the standard. Are we together? Yes. So in case you use that digital ohm meter and you measure the resistance, which expected to be 10 kilo ohm, and maybe you measure the resistance is 8 kilo ohm, then this instrument needs to be calibrated. Are we together? Because the standard resistance is 10 kilo ohm. Hello? Then itself, it measures 8 kilo ohm. So what is the deviation? 2 kilo? Right? So you have to calibrate. So you'll know that this digital ohm meter is not calibrated because it's giving me wrong readings. Also, another way, if you want to calibrate a voltmeter, for instance, then you have to use non-voltage non-voltage. For instance, we have 9 volt batteries. 9 volt battery, or we have 12 volt car batteries. So you must find the source of voltage, but it's standard, it's known. Then you are going to use that DC voltmeter to measure it. In case you find the readings is different from the one you expected, then that instrument needs to be calibrated. Are we together? Yes. Yeah. But how did you know that you are supposed to calibrate? Because you use the standard known quantity, physical quantity. Is it clear? Is it clear? Number 3, or the steady state of calibrating the instrument. Adjust the instrument's calibration. Adjust the instrument's calibration. The instrument's calibration controls it's not underlined, but just I want to show you the keywords. Controls as needed. So this is just the description. As what? As needed to match. As needed to match the standard. To match the standard. So adjusting the instrument. This is the steady state. Say adjust. In the second state, you have noticed that the instrument or the measuring instrument gives you wrong measurements. You need to calibrate. So in the steady state, the manufacturer will teach you how to fix. Okay? So what you are supposed to adjust the instrument calibration controls. Say instrument calibration controls. I can say instruments calibration controls. Some of the measuring instruments, they can have special buttons for calibration. Right? That's what we call the instrument calibration controls or knobs. Then as needed to match the standard. So you have to adjust it until you find that. So how are you going to adjust? Listen. For instance, that this is your instrument that you need to calibrate. Maybe this is the dictiometer, right? The standard reference you have, the standard reference resistor has a resistance of 10 kilo ohm. Okay? But before calibrating, when you measure the its resistance is 8 kilo ohm. So you have to adjust the control knobs of that dictiometer until the display of the dictiometer measure 10 kilo ohm or 9.9 kilo ohm or 10.1 kilo ohm. Are we together? Yes. Yeah, so that's the point that you have to remember. Is it clear? To match the standard. Where the standard is this one. Precision resistor for resistance. Or non-voltage source. These are some examples of standard. But each measuring instrument has its own standard. Okay? And when you talk about standards for the electronics measuring and the testing instruments, you have to think about TBS. Say TBS. So TBS, they have a standard department. Are we together? And from this concept, you may notice that why those physics practicals of light, electricity, and heat that we have been just performing in our science labs in O level and the A level were not actual giving us correct results because of the deviations and errors which sometimes has been caused by instrumental error or environmental error or parallax error, or we call it because you have instrumental error, environmental error, but we can call them some special names. Systematic error and what? You forgot types of error. Number 4, the first step of calibration. After calibration, so you have done it in the steady state. After calibration, check the measurements. Check the measurements. So after calibration, check the measurements. Again, to verify accuracy. To verify accuracy. So after calibration, check measurements. Say check. Check measurements again to verify what? Accuracy. So that's why we call it calibrations and what? And accuracy. So, but you have to know that how do we check the accuracy specification? Then the instrument or the manufacturer will actually declare accuracy specification. Say accuracy specification. For the different instrument. For instance, stop writing. In the user manual, you see that the accuracy specification called the voltage measurement. Say voltage measurement. So the voltage measurement, actual accuracy specification will be plus or minus what? X percentage. What does it mean? This is percentage error. Do you remember percentage error? It means this is tolerable error. We call it in other words tolerability. That's why if you do remember that, in practical physics and practical electrical, we call it, we can write that voltage is equal to, let's say 2 plus or minus 0.01 volt. Okay? So this one is voltage UT or accuracy UT specification. Right? So it's allowed to vary with variations of 0.01 before or below 2 and after what? 2. Are we together? So this is the voltage measurement. So it should be plus or minus. Then find the value here in terms of percentage. Okay? Again, for the instrument that will be measuring current. So in its part of calibration, the accuracy. So you have what? Current what? Measurement. Say current measurement. So it will be plus or minus. Then open bracket XC, then percentage. Are you together? Number 3. Another one, for instance, that resistance measurement. Resistance, the accuracy of resistance measurement. We say that this one is plus or minus what? X percent. And sometimes you can find with unit. Maybe this is voltage. This one is current measurements in terms of ampere. This one maybe I say resistance measurements in terms of what? Ohm. Class, are we together? Yeah. So that's what you have to know about T, or that's what you should expect to learn from user manual of electronics measuring and testing instrument. Let me know if there are questions about calibration and accuracy. Do you have a question? No. Brother? These are the industry information. These are the site information. You have a question? No. Go. If you don't have a question, then let us discuss the 7th part. So the 7th main part of user manual. That's called what? Trouble. Very important. Troubleshooting. Very important and sensitive part. Say troubleshooting. If you are a technical electric engineer, you know one of the challenging parts is troubleshooting. You may spend the entire night, you may spend the whole week, you are still troubleshooting the just the one machine, and then you don't see anything else. And sometimes a team of engineers might be actually spending some time to troubleshoot and figure out that, boss, we have to call expert. Okay, so this is a very important terminology in electronics, in electrical engineering, electronics engineering, telecommunication engineering. Against class A, troubleshooting. Say troubleshooting. Yeah. So there's a definition of troubleshooting. There are 3 types of troubleshooting. We have preventive maintenance and what? Corrective maintenance. And the other ones we call scheduled maintenance. So simply troubleshooting, we say that finding a problem and fixing and preventing not to reoccur again. Okay? So then with this measuring instrument, the manufacturer also will give you some ideas about what are the troubleshooting steps that you may perform in that particular measuring instrument. It doesn't mean that you can troubleshoot every problem. No, some of them if you have a warrant, you have to return back to them. Okay? But these are the simple troubleshooting that any electronics engineer or electrical engineer might perform. So in case of troubleshooting, what do we find in the sentence? So if the instrument is not functioning as expected, that's the sentence. If the instrument is not functioning as expected. So it's not function as expected. Check the following. So if the instrument is not functioning as expected, it's not functioning as what? Expected. Then check the following. So the manufacturer will give you some key concept. Okay? Check the following. Number 1, what should you check for? Maybe, for instance, the problem is a no display. No display of 40 of the measured values. How can you do troubleshooting for this case? Say no display of measured values. Say no display of measured values. These electronically measuring and testing instruments, most of them they have display. To display the measured value from the print on the circuit that you are measuring voltage, or you are measuring current, or you are measuring resistance, or you are measuring frequency, or you are measuring maybe you are measuring capacitance or inductance, etc., etc. Okay? So we say that no display on the measured values. What should you do in case you don't actually you have taken the test leads, you connected to the two testing points or to the points on the circuit, you don't see any figure or any digit on the display. What should you do? So the manufacturer will give you some information, okay? So here the manufacturer actual will ask you to do the following. Number one, ensure the power is on. Ensure the power is on and the battery is not depleted. This is the first troubleshooting that you have to do. Separating. Say ensure the power is on. Say ensure the power is on. I said separating. And the battery is not depleted. Sometimes you may take the test leads of the multimeter, or maybe you are connecting the outputs of the circuit into the digital oscilloscope, while the oscilloscope or multimeter is not turned on. So if it's not turned on, don't expect to see any reading on the display. Number two, digital multimeters are using batteries, right? So these ensure the battery is not depleted. It means the energy stored within the battery is not totally consumed. It means that the battery, check if the battery has drained. Okay? So you don't see the readings on the display, maybe because of the battery which has been drained, so you have to change. Okay? Okay, class? Yeah. It's just like you yourself. If you don't understand what is Olenjolai teaching you, then ensure that you have turned on your power, your mind, but also check that maybe you are suffering some biological consequences that call the hungry. Maybe you are hungry, so you need some energy to understand, but your stomach is empty. Right? Yeah, so something like that. So even these electric instruments, they also need some food, and their food is electric energy. So the food is not there in the storage. How do you expect the output? Then after that, then another troubleshooting that you have to check, this no display of the measured values or no display of the measured of the readings might be caused with what? Loose connection of the probes or test leads. The wires that connecting the instrument to the 2 points of the circuit, they might be loose. Say loose. When you say loose connection, you understand. So loose connection. So recheck if the testing leads or probes are loosely connected. To the instrument or to the circuit. So if the probes or the leads are loosely connected, then don't expect to see any reading on the display. Okay? That's the goodness of having or going through the manufacturer's mind, because he knows, or he or she knows well the product at your hand. Then that's one of the challenge that you may encounter. The second challenge in troubleshooting that you may troubleshoot, difficulty B, is incorrect reading. What if you have incorrect reading? Say incorrect reading.
Incorrect reading.
What you have incorrect reading, and you observe that this incorrect reading is not caused by calibration, but it causes you with some other problems. What you have incorrect readings. Then, number one, the troubleshooting steps: ensure the range selector is set to the corrective function. The corrective function. So ensure the range selector is set to the corrective function. Listen, this is very important sentence. Ensure the range. Say range selector. We discussed range selector in lecture 4. Range selector is set to the corrective function. But let me remind you, what does it mean? The range selector, mostly are using something called the rotary switch. Say rotary switch. Say rotary switch. Here we have an arrow to indicate the position. So you may find that this is off. You may find that here we have voltimeter. You can have AC, you can have DC voltimeter. You can have maybe this one, this point, you'll have what? You'll have, okay. You'll have maybe, you'll have millivoltimeter. AC millivoltimeter and what? DC millivoltimeter. At this point, hello, hey. Huh? Here you may have what? Let's say ammeter. AC ammeter, DC ammeter. Okay? So maybe your intention you want to measure AC voltage by using AC voltimeter. Unfortunately, you set the range selector or the rotary switch, then you have set this digital multimeter into ammeter. Okay? So for that case, you'll get wrong reading, because the ammeter should always connected in series with the circuit, while the voltimeter should always connected across the two testing points, which you call higher potential and lower potential. Or in other words, the voltimeter is connected in parallel across the 2 points. So you set this digital multimeter into ammeter by using the range selector, but your intention you just want to set here. So do you see that you'll have incorrect reading? That's the means of that sentence. Okay? So in case you get incorrect readings, the manufacturer asks you, please cross-check the range selector. Maybe you positioned it wrong. Are we together, class? Is it clear? You don't need to claim this material. Just need to understand and then enjoy them. The second day, troubleshooting steps for that case. So this is just for demonstration. You have to write and round that just for the demonstration, for understanding what has been said in this sentence. Okay? Okay. Well, number 2, we say that recheck the connection of the props. Recheck. This is very important again. Recheck the wrong or loose connection. Loose connection of 40 of the test leads. Of the test leads and what of the test leads or tested props. This is a very important troubleshooting step. And you have to listen. Say, recheck the wrong or loose connection of test leads or test probes.
Check the wrong or loose connection of test leads.
Well, so what the means of this sentence? It's very important. So maybe you have ensured the range selector is set in the correct function. You have to check the test leads and test probes. Test leads and test probes are the wires used to actually transfer electric power from the instrument towards the circuit. Are we together? So test leads are actually nothing, insulated wires. Okay? Where there's the two tips. And you have positive test leads and the negative test leads. In lecture 4 we discussed and I demonstrated. In the next lecture will come with the dictum multimeter actual to show you about those test leads, because that's the point that where we are using them. Okay? So cross-check your wrong connection or loose connection. So loose connection, let me, for the dictum multimeter that we are going to use, it has 4 terminals. We have something we call them terminals. Say terminals. Say terminals. It has 4 terminals where that you can plug the test leads. Okay? The first terminal, this one, is written 10 ampere max. This one has been written what? I think that it is written milliampere. Actual, it means 10 ampere, milliampere. Then this one, the third one is written COM, the dictum multimeter that we are going to use. Right? I will show you, I will see it. Then this one is written the terminal for the voltage or voltmeter, then ohmmeter, then capacitance meter, where we use the symbol of capacitor, capacitance meter, then frequency meter. So listen, we have 2 types of test lead, red test lead and black test lead. Okay? Loose connection is actual. If you want to measure voltage, for instance, the red test lead should be connected in this terminal, while the black one should be connected in this terminal. Okay? So the connection is, for voltage measurement, the connection is correct, but maybe these probes are not properly plugged. They are losing. They did not make a contact with another conductor within the dictum multimeter. Okay? For instance, hello? This is the hole. So it means that this is the plate. So remember that currents always flow in closed loop. If the loop is open, there's no flow of current. The electric engineers. Okay? Currents always flow in closed loop. We have always a wire that's sending current to the particular place and a wire that's returning current. Simply have live wire and neutral wire. The philosophy there is the live wire will be carrying large amount of current that will be working to operate the instrument, right? Then the neutral wire will be carrying small amount of current because it is returning to complete the loop. Similarly for DC, we have positive leads and negative leads. Positive leads corresponding to live wire in AC, and the black leads actually corresponding, or negative leads are actually corresponding with what? Neutral wire in AC power. Are we together? So remember that if there's open loop, currents cannot jump. Right? Do you understand when I say closed loop and open loop? Closed loop is just like this one. If current is actual starting from here and circulate, then there's a flow. Right? But open loop, we say that like this one. There's no flow of current for this case. Are we together? Are we together? So for the loose connection, it means that the lead did not make a contact with the conductor through terminal in the dictum multimeter. Are we together? Are we together? Then let us come about wrong connection. Say wrong connection. Maybe you want to measure voltage. No, you want to measure current. If you want to measure current, the black test lead should be connected in COM terminal. In COM what? COM is abbreviation of common. Say common. So this is the common terminal for this, is a common terminal for this, It's a common terminal for this. So common is something which can support two or more than two. Are we together? Yes. So the black list is always connected in the common, but the red list has to be changed according to what you are measuring. Are we together? So maybe you want to measure what? Current. If you want to measure current, the red test list has to be connected. Has to be connected what? To either in milliammeter or in ammeter. Okay? Unfortunately, you forgot that the red list is in this position where that you can perform capacitance measurement, voltage measurement, resistance measurement, and frequency measurement. For that case, you'll have incorrect reading because your intention want to measure current, but the test leads are wrong connected. Are we together? Are we together? And sometimes the common mistake that I encountered even myself when I was beginning to do measurements, when I plug these ready test leads, maybe I plug it at this point, then I finish the experiment, maybe I turn off the digital multimeter, maybe I continue some other business. But I forgot maybe to return this one or to return the test leads into this hole. Then you find that I want to measure voltage, but unfortunately the test leads is connected in this terminal and the common is there. So I'll get wrong reading. I used to get wrong reading. Then because I read the user manual of that digital multimeter, then I know, maybe I have wrong connection of 40, ready test lead. Are we together? Are we together, class? We have discussed about how connecting these test leads in lecture 4. We should not worry about that. Okay? And we'll review it when we'll be learning about the digital multimeter. So that is in case you have incorrect reading. The last troubleshooting part, I'm about to end this lecture. Then we'll be discussing about other 3 parts in the lecture 60. The last troubleshooting part, which is C, is called unstable reading. Say unstable readings.
Unstable reading.
What if you are getting unstable reading? Do you know unstable reading? Fluctuating reading. You expect to measure 9 volts, then you find that sometimes it is 2 volts, sometimes 5 volts. You know the experiment will end there because you say, it's confusing me. Okay? So then the manufacturer has to say something about unstable reading because sometimes it is a technical problem. Okay? Or sometimes it is the actual, it's a problem of your circuit. Okay? So the manufacturer tell you that for unstable reading, number one, check for electrical interference. Check for electrical interference. Check for electrical interference in the measurement environment. In the measurement environment. That's the first procedure. Check for electrical interference. Say electrical interference. You are electric engineering students, you know that electric signal might be interfered by what? Presence of the electromagnetism, electromagnetic field, right? Presence of maybe some noises and etc. So maybe that might cause the OT, or maybe electric interference within your circuit. Okay? That's one of the case. Number 2, ensure the test leads or probes. So ensure that the test leads or probes are securely attached to the measurement points. To the measurements measurements or measurement points. Ensure the test leads or probes are securely attached to the measurement points. That's what we've discussed. Sometimes you may get OT unstable readings because of the test leads or probes are not properly OT. Are not properly OT? Yes, ensure the test leads or probes are securely OT attached to the OT. But now we are not talking about terminals. Stop writing. Attached to the measurement points. Now we are no longer talking about terminals. Listen. We are talking about the measurement points. Say the measurement points. Say the measurement points. For instance, this is the circuit that you want to measure. This is the circuit that you want to perform measurements. This is R and this is LED. Then we say that this is positive, just like this one. Then for this case, we have this switch. Okay. So resistance, this is LED. Suppose that this is LED. You want to measure voltage across what? Across this. So the testing points are this one, across LED. This is testing point A, this is testing point B. Okay? So sometimes maybe you did not make a contact between the anode of LED and the positive test lead. Or maybe you did not make a physical contact between the black test lead and the cathode of LED. For that case, you might get OT, or maybe you are connecting, reconnecting, or maybe you are shaking. Actually, your hands is vibrating or shaking, right? Connecting and so it means that connecting, reconnecting, disconnecting, connecting, disconnecting. That's the meaning. Are we together? Then finally, in this section, the manufacturer will tell you that if I said that if the instrument, if the instrument is not functioning after performing all of these steps, then refer the warrant and and support. Say warrant and support. So warrant and support, it's a tense, it's a last part. It means that you have followed all of these procedures to fix up the problem, but it's still persisting. Then you have to check the warrant if you are. So when you check the warrant, when you purchase that digital or that electronics measuring or testing instrument, then it comes with a warrant, and that warrant defines the time, maybe free maintenance in 3 months or 6 months or a year, right? So check the warrant if it is still valid for you. So if it is still, you have to send back to the manufacturer, and manufacturer will do troubleshooting, further troubleshooting within the electronic circuit, fix it and return it to you. If the instruments will not be successful repaired by the manufacturer, then the manufacturer will send the new instrument to you in order to guarantee business between you and the particular industry or company. Are we together? Yes. Did you understand the lecture? Yes. Did you enjoy? Yes. Well, so I would like to say that I thank God to have given me a chance to teach you and to share with you this very practical information. We are discussing them in theory, but when it's come for the application, it's a serious issue, And many technicians in our country and engineers, they fail to read and understand manuals and use them to figure out some problems. Because in electronics, you have user manuals and data sheets. Data sheet is for electronics components. User manual is for the instruments or devices. So I would like also take this opportunity to thank you who have joined me in this lecture. And I would like to welcome you in lecture 60. And let me tell you what are we going to discuss. We are going to discuss the other three main parts. Okay? Which number 8 is what? Maintenance and the care. What the user manual state about that. And number 9, we discuss about specifications. What are the common specifications you'll find? And the lastly one, the one we've mentioned here, warranty and the yes. After that, we have covered user manual and we have covered the first topic. We'll move into the second topic. So I'd like to thank you, and because I always appreciate students when they learn and understand. So now it's the time to congratulate you. Get prepared. One clap a hand for you. 1, 2, 3. Hongera. Imara. Wow, that's how we finish all my lectures. We always finish with joy, because when you say hongera, imara, wa, we used it to finish the day during our primary or nursery school. And by that time, we did not have stress. We were just thinking about dancing and enjoying life. Life was good by that time. We did not have any stress. But now, when you finish this class, you remember about marriage, financial problems. You have so many. But that time, your father and your mother are the one who are responsible. You are the big boss. Thank you very much. See you in the next lecture.
Tanzania.